Hello and welcome to another coding session. So today is not really a special day, but yet another day of developing our text editor. That's right, and everything is fucked up. I'm really sorry about that. Let me actually quickly fix that. So yeah, today we're going to continue developing this text editor, which I've been developing for, I don't know for how long. I think I recently started developing this thing. But the idea of this text editor is to make it as dramatic as possible. So that's why it's called a dramatic editor, or dead for sure, right? So there's two reasons why it's called dead. Is because it's dramatic, and the second reason is because nobody's gonna fucking use that because it's a piece of shit. So you can find a link to this to the source code of this editor in the chat if you're watching live, or you can find it in the description if you're watching that on YouTube. For people who's watching on Twitch, this is the YouTube channel I keep talking about. Yes, so if you are a Twitch person and you want to become the YouTube person who's getting all of their information from the description down below, just subscribe to that channel. And if you are the YouTube person who's getting all of their information from the description and you want to become the live Twitch person, just follow me on twitch.tv/sodding. So you can be whatever person you want to be. Seriously. Just go to the corresponding place, just hit subscribe or follow, and you can be whatever you want to be. You see? It's that easy. It's that freaking easy. So yeah. Let me go to the source code of this thing. I think we're gonna do it here. Hello script sh, what's up? What's up, what's up, what's up, what's up? Beacon. So let's fetch the latest stuff. I don't even know what we're gonna do today, but we're definitely gonna do something. It's not fully merged. What the fuck? I suppose I have to fetch everything. Merge origin master, and let's rebuild everything in here. Okay, and let's try to run the text editor. This is the text editor. You see, the cursor is at the center of the screen, making it very, very dramatic. And let's try to type something. And we have like zooming, we have like panning of the camera and stuff like that as you type, right? And that's what makes this text editor very, very dramatic. That's why it's called a dramatic text editor, right? So the reason I'm making it is just for fun, no particular reason, because I have no life. So I just need to do something to, to not feel the existential dread, and that kind of helps me. So yeah, that's precisely the reason why I'm doing it. People keep asking me, why, Zozin, why are you doing that? Do you have some sort of like a global goal? Do you want to make the world better? No, I just don't want to feel bad. That's it. So yeah, that's why I'm doing all that. So there's no particular reason, just enjoying myself. 1, 2, 3, 4, and this is gonna be that. 1, 2, 3, 4, and print f hello world. Right, so there we go. We wrote the hello world in this text editor. So there we go. It's pretty cool. So I was thinking what we're gonna be working on today. I think one thing is missing to make this text editor even more dramatic than it is, and that thing is zooming. You can pan the camera moves around, right? The camera moves around and shit like that, but it doesn't zoom in and zoom out for more dramatic effects. It would be kind of cool if you, for example, if you want to jump to a particular place in the text, the camera would zoom out and, like fly away, and then slowly like land in a particular place. It's not just like slowly zooming, but it's actually zooms out and moves there and then zooms in like that. So it's just like, so you can think about the text sort of like a 3D plane, and you basically move into a particular place on a curve or something, right? So that would be actually kind of cool, I think. So we'll see how we can implement this kind of shit. So yesu, kawaii freaking desu. Kawaii freaking desu. So I think I even created the to-do for the zoom. Right, so here is the zoom to-do. So this is where we're working with the camera and shit like that. So the camera has a particular position and also it has a particular velocity and stuff like that. So I think the easiest way to add the zooming, first of all, I think we need to actually create a separate branch. I'm gonna call this branch zoom. Right. Is to go to the shaders and in a free glyph shader, I think we're going to do that on the vertex shader level. Right, so we may try to introduce something like a uniform vector to camera scale, right, and this one is going to be actually float. And after that, I'm not quite sure how we can scale this entire thing. So here we transition in everything, right, so this is the transition, and maybe after the transition, right, after the transition we need to multiply this entire thing by the camera scale, right, and by controlling camera scale we're gonna actually, you know, change the appearance of the characters. Hello Stop Gaming 50, hello A2P1K04. Elazor, thank you so much for 8 months of Twitch Prime subscription. Thank you, thank you, thank you, and welcome to our epic Dead Club. That's right. My glasses are dirty. Just like my thoughts. Nice. I didn't clean my glasses, I just smeared the dirt all over them. Okay, so maybe we can actually test the camera scale by not really making it a uniform, but rather a local variable, at least for now, because if you make this thing a uniform, that means you have to set it from the C code, right? You have to set it from the C code, but I don't want to set it from the C code for now. I want to set it from the shader code. To be fair, I think the GLSL is a better language than C. Because at least it's strongly typed, right? So the type system of GLSL is already better than the type system of C. Yeah. Can somebody make GLSL into a real programming language, which is a competitor of C? That would be actually kind of cool, I think. On top of that, GLSL like implicitly supports function overloading. I'm not sure if you can have your own overloaded functions. I think you should be able to, right? GLSL overloaded functions. Can you define your own overloaded functions? So that would be kind of POG, if you know what I'm talking about. Yes, it is true that relational operations only work on scales where blah blah blah. Okay, that would be actually kind of interesting. Okay, so I'm gonna put 1 in here, right, and we're gonna try to run this entire thing, right? So we're gonna try to run it, and there you go. Everything seems to be working. But now, what if I define, you know, a function that accepts a particular float, right? So here's the function, it simply accepts the float, nothing special, nothing magical, and it seems to be compiling. What if I define a second function like that, but this time it's accepting something else? Will this entire shit still compile? It is still compiling, and now, for instance, if I do something like x+1 in here, and in here, maybe I should actually return the float, and here it can be back 2, right, and here it's going to return x plus, maybe multiply by 2, something like that. So this is a free glyph, so, okay, so I forgot some semicolons in here, let's actually put semicolons, and it's still compiling, so, and I suppose, regardless of what you're doing in here, right, so if I put f in here, it should work correctly. Okay, that's pretty cool. So we already have a zooming, but we have a zooming on a level only over characters. Yeah, my point is GLSL apparently supports function overloading. It's pretty cool, I guess. I think it's pretty cool because you can have sort of like a compile time polymorphism, right? So yeah, somebody needs to make like GLSL, you know, like a language for CPU, right? So the semantic of GLSL and just make it a competitor of C. That would be actually kind of pogue. And if you're a C developer, it would be super easy for you to switch to GLSL or something like that. It's just, I don't know. Holy C is GLSL. Holy C is dynamically typed. Have you even programmed in Holy C? I would assume you never programmed in that language. So you probably don't even know what you're talking about. It doesn't check any types. Seriously. Essentially, it basically translates everything without regarding like type checking and stuff like that. So if you mess up the types, the generated assembly is just going to be incorrect. So people who prize like Holy C is such a good, none of you actually programmed in that language. I can tell you just by what you say about this language. So yeah, of course, none of you programmed in it. I watched an old video about the battle between C and Haskell. How did you lose so much weight? I stopped programming in Haskell. That's how I did that. So if you want to lose weight, just stop programming in languages for nerds. Oh, dumb. That's how you become a chat. I'm sorry, I'm joking. I actually stopped eating too much carbs, and that's how I lost the. All right. So, but what if you don't program in Haskell? Well, maybe you program in Haskell, but subconsciously. All right. So let me see. I also do, but doesn't work. You're lying. And first of all, you're lying to yourself, actually. I don't need any carbs, and just like secretly adding shit ton of candies. Like I know people like you. Come on. You're not fooling anyone except yourself. Seriously. Like, you don't have to fool me, I don't care. You're the one who cares, right? So don't fool yourself. So let's continue. Right, so we have a scale in here, and yeah, so we do have support for these kind of things. So we can try to do something more interesting, right? So we can add additional thingy in here. For instance, float time, and it's going to be sign of time, right? So here is the sign of time, yeah, the sign is from -1 to 1, so this is going to be the usual thing, right? So this is going to be the usual thing, and we're going to actually divide it by 2, right? So there we go, and that's basically what's going on in here. You can make the code pulsate, or whatever the fuck is that supposed to mean. Yeah. I eat sweets on Saturday, but only lost 4 kilograms. It's actually a pretty good rate, in my opinion. I ate nothing but proteins for several months. That was hard, and I thought I'm gonna fucking die. So that's the answer. And I do not recommend doing this kind of stuff, but I had a really bad body dysmorphia, so I had to do that. So let's continue. Now let me see. Can we actually speed it up? I think we can try to speed it up like twice as much. And we can even try to open this thing in like this kind of thing. Yeah, there we go. It's actually pretty pogue. So it's kind of funny how cursor doesn't obey the you know, the zoomage, if you know what I'm talking about. It doesn't care about the zoomage. It kind of does, but yeah. This is way too dank. Well, I mean, we can speed it up if you want to. Right, so it's gonna be twice as much. Let's say 16. I think this one is gonna be nice. So try to edit something in this text editor. No, that's what I call a text editor. Who fucking needs Vim? Who fucking needs email? Can your Vim do that? I don't fucking think so. Your Vim cannot do shit. Right, so it's gonna be .h. And this is gonna be like that. And fuck! Shit! Fuck! Damn! Alright. So, I think we need to also add this kind of stuff to the cursor. Where is the cursor shader? And all of that on the shader, by the way, all of that is done on the level of a shader. And by the way, you want to see something? You want to see something cool? We are offline, but I'm still recording. So, those of you who's watching on YouTube, you're looking at an exclusive content right now. So Twitch people cannot hear us. Twitch people cannot. Oh, we're live again. Fuck. We're live again. Shit. All right. So the thing is, okay. The thing is, I'm actually recording it as well, so we didn't really lost any footage. So I thought I had an opportunity to talk shit about Twitch people, but now I cannot do that. So you YouTube people can see everything, but Twitch people sometimes might not see everything. Nafli, hello, what's up? How are you? All right. So camera project or something. Oh yeah, I wanted to add this kind of shit to the cursor, right? So I wanted to add this shit to the cursor, and in here we have like a little bit of a code duplication between different shaders, and I wonder, is there any way to just code reuse between the shaders without the include and stuff like that? Okay, so let's actually try to Google that. GLSL code sharing. How do you share the code? Sharing code between multiple GLSL shaders. Because sharing is caring, right? Okay, comrade. Alright. So there is a bunch of approaches, but none is perfect. It's possible to share code by using attached shader to compile shader, but this doesn't make it possible to share things like struct declaration or defined constants. Oh, you can actually link those metaflippers together. This is actually pretty cool. I didn't know that. That sounds like a pretty cool idea. Some people like to use array of strings passed to as a way to prepend common definitions and stuff like that. Due to the statement share, you cannot use prepend text. Okay, so but does it mean that you can have like you can forward declare some of these things? Right? Can you forward declare this shit? That's actually sounds interesting. So if I try to, so this is the free glyph, and apparently you can, right? Free glyph vert. And if I try to do something like this, if I don't have an implementation, it should have failed. But did it fail? Saying that cannot find implementation. Unresolved rep. Okay, that's pretty powerful. So I can take all of my common code. Right, I can take all of my common code, put it into separate shader, right? Put it in a separate shader, and then forward declare only the functions that I need, and just link with that shader everywhere. GLSL has an actual linker. Nafli, you've been programming in OpenGL recently. What are you talking about? Did you know that, like, when you called GL link program, I'm pretty sure at some point of working with OpenGL, you called this function. And you still have any questions whether it has a linker? So, didn't that look sus to you? Like, this is really, really sus. Why is it called link, right? You know, it's like literally in the name. There's something sus going on. Well, I mean, come on. It's the same kind of linker like in C. I'm not sure if it's the same kind of linker in the C, but semantically, I mean, you probably mean semantically. Yeah. I also didn't know that you can do this kind of shit. I just discovered it, so. Alright, so yeah, I need to test that. I really want to kind of test that, but I'm not sure how we're gonna test that. Also, when we're compiling the shaders, right? When we're compiling the shaders, we're supposed to even like say what kind of shader it is, like whether it's a vertex shader or fragment shader or something like that. Right? Vertex shader or fragment shader. And can I just have a common code for both fragment shader and vertex shader. I'm not sure. And here's another thing. We're linking together vertex and fragment. What if I have two vertex shaders and two fragment shaders? Can I use the definitions in vertex shader in a fragment shader? Is that something I can do? This is the good question. Is that something that is possible to do? It raises so many questions, actually. It raises like a lot of questions. Okay, so we can try to do something like, so here is the vertex shader, right? And what we can try to do, we can try to define a function f, float f, let's put it like x, right? Maybe we can even do something like vec2. Here's a vec2, and that vec2 essentially just takes the x and adds y, right? So here's the f, and the question is, can I use this function from the fragment shader? Is that something I can do? So this is going to be cursor frag, and interestingly enough, I can probably do something like a GL frag color, right? GL frag color, and I'm gonna just which one do I want to do? I think I want to do UV coordinates, but I'm not sure if I do have UV coordinates. Okay, so this is a cursor shader. I don't even have UV coordinates in here. I think I need to try to do that in a glyph shader, right? So it has to be done in a glyph shader. Okay, so here's the glyph thingy, right? And then we're gonna have a free glyph vertex, right? It's already vertex, and in here, so here is UV. Well, I mean, I'm still looking at the wrong thing. This one is going to be free glyph fragment. This is that. And I suppose this is going to be GL frag cola. And I can assign vector for FUV. Right, so we do have FUV, then 0 in here, 0 in here, and 1 in here. There we go. So this is going to be purely red, and hopefully it will show some interesting patterns. Maybe, I don't know. We'll see. Maybe we can even do something like, well, whatever. Okay. If I try to run this entire thing, right, it's not going to work. It's not going to even compile. No function with the name f. But if I forward declare it in the fragment shader, right, if I forward declared it in the fragment shader, it is kind of working. It is kind of working, but at the same time it is not. Okay, so if I try to run it, and if I take a look at this kind of thing, so what does it say? GL is program 3 not linked. That is really strange. Why is it not linked? Why is it not linked? Promoted something. So it kind of worked, but if I, for instance, put this thing in here, right, and if I just run it, yeah, okay, so this looks like a proper pattern, right? So this is roughly the pattern that I expected in here, right, but if I just remove it and rely purely on the one from the vertex, I won't be able to use it from the vertex shader. So there's another hypothesis that I would like to check is, what if it's defined in a fragment shader, in another fragment shader? Will it just work? So, and the question is, how can we check this kind of hypothesis? How can we check this kind of hypothesis? Do you have a CS degree? No, I don't have any education. I didn't even go into a middle school. I have 0 education whatsoever. Is that intentionally when you press right arrow at the end of line several times and then left arrow it doesn't go back immediately? Yes, it is intentional, and you know the reason why it is designed like that? Because the text editor is not fucking finished. I developed it for like a week or so. Anyway, so I'm literally in the middle of developing the text editor. It's not fucking finished. There's a lot of things that are missing here or working incorrectly. Yeah. It's just like, I know the concept of software, you know, being developed and, you know, looking at software in the middle of the development and being finished is rather strange, because you probably got used to the concept that software just appears out of thin air, but it is like that. Unfinished software is like that. Yes. All right. Wait, what? You didn't go to the middle school? Yes, I didn't go to the middle school because it's a waste of time. Education generally is a waste of time. All right. Wait, what? Software takes time? I know, right? Fucking crazy. And you know what? Software is actually developed by people. Somebody actually sat down and wrote each individual character. Holy freaking shit. It's developed by people like you and me. Wow. Holy shit. Amazing. Fucking amazing. Okay, so let's actually try to put this thing like into a separate module. Let's call it reusable. It's gonna be GLSL, and I wonder if... Yeah, there we go. So there's also cursor by people without middle school. Yeah. Experience and passion is worth much more than degree that teaches the theoretical background. It has to be written in this, like, you know, the italic font with the inspirational background. It's just like, yeah, the passion means more than experience. Ah, I'm 14 and it's so fucking deep. All right. Let's continue. Passion. We need to understand, chat. We need to understand. Is it even possible to reuse shit within GLSL shaders? Is it even possible to do this kind of stuff? Because that will simplify a lot of shit. I know it's boring, right? I know it's boring because we're talking about actual programming, talking about actual software development, but we have to do that. Somebody has to do that. As we already established, the software is not appearing out of thin air, so that means somebody needs to sit down and actually fucking write it. So let's fucking write it. I know not everybody likes that, but it is what it is, and it isn't what it isn't. Alright, so we have this shit, and for some reason it still doesn't work. Let me take a look at what I screwed up in here. Yeah. So I probably need to get rid of this specifically. Right, so there we go. So we have this kind of thing. Unfortunately, right now, our linker, shader linker, is incapable of taking more than 2 shaders. Right, so this is kind of a problem. So maybe we're gonna start with actually extending this entire thing, right? So there we go. Link program, and as you can see, it accepts only 2 of them. It would be better if this function would accept an array of shaders. So you have shaders and stuff like that. And I think you have to do something like GLU size. I think it is a type within GL, within OpenGL. And maybe it's actually GL size I. I think it's a GL size I. And the one that I care about is probably GL size U, and there's no such thing. Okay, fuck it then. This is gonna be size T, shaders, shaders count, right? So, and I want this program to actually iterate through all of that, right? And just link all of the shaders together. Okay, so let's go ahead and do that. So we're gonna do something that I call compiler assisted refactoring, right? So I broke the program and I'm gonna follow the compilation errors and I'm gonna fix all the compilation errors, hoping that this shit is going to work. Praying that this shit is going to work. To the gods that make software appear out of thin air. Right, that's how we develop software. We just pray until software appears, right? So sometimes it appears unfinished, right? So sometimes it appears unfinished and we need to pray more so it gets finished. That's how we do that in the industry. So, and in here, basically, we're gonna replace these two lines, right? Since we only supported two shaders, we need to replace these two lines with a loop that iterates over all of the shaders. Right, so this is going to be something like that. It's going to be shaders count plus I, and what I'm going to do here is just like a boom, 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 there we go, done. So that's how we can do that. But in all the places where we use this function, this shit is not going to work, right? So we'll have to adapt everything accordingly. So let's go to the places where it's going to fail. Okay, so something. Why are you not happy? I don't understand. Implicit declaration of GL program. Did I put Q in here? I think I accidentally put Q in here. Alright, so, and after that we're deleting all of the shaders. So we can do that in a loop as well. Why not? I don't see any problems with doing that in a loop as well. So it's going to be shaders I, we're going to remove that, we're going to do that, and there we go. And here is a pretty cool thing. Here is the pretty cool thing. We are compiling the shaders, right? We're compiling the shaders, but there's only two of them, and we are returning their IDs via the pointer. So I suppose one thing we can do, we can now have shaders, right? And let's say that we're gonna have two shaders in here, right? And the vertex shader, I suppose, is going to be shaders 0. So this is the zeroth shader, and the fragment shader is going to be the first one, right? And we don't need any of this shit anymore, right? So we basically have an array of shader IDs, and then we should be able to actually pass the shaders, and the count is going to be 2. But what I'm thinking is that maybe we can define something like shaders count, right? So shaders count is going to be 2. Okay, for now we can just use the usual C trick: size of shaders divided by size of shaders 0. There we go, and that will hopefully work. So the reason why I'm refactoring all of that, so it's easier to add more shaders into the linkage, if you know what I'm talking about. So here is here is another situation. Oh, it's a different renderer. We'll have to do that for each individual renderer. We'll have to do that for each individual renderer. Alright, so that should be fine, I guess. So let me just go ahead and do that. So GL uint shaders shader2, we're gonna initialize that with 0. There we go. So this one is going to be shaders 0. The first one is going to be that one, shaders 1. It would be kind of cool to even have enumerations for these kind of things, right? And each value enumeration corresponds to a shader, but we're going to do that a little bit later, right? So this one is basically shaders, size of shaders divided by size of shaders 0. There we go. Is it going to work? Is it going to work now? Yo! Almost. There's another place where we have to do, oh yeah, so there's at least 3 places where we'll have to do the same shit over and over again, because we compiling 3 different programs. The first program is the one for rendering the glyphs, the second one is the one for rendering the glyphs but in monospaced font, and the third one is for rendering the cursor. Yes, well, I mean, it's segfault because everything is broken right now, but you saw the cursor in the editor. That cursor is rendered by a separate program. Yes, it is rendered by a separate program. Shader program, right. Okay, so what do we have in here? GL uint shaders is going to be 2. It's going to be 0. We're going to remove that. We're going to remove that. And this one is going to be shade. Well, I might as well actually do something like that. Look. We're going to do a little bit of Emacs magic. Shaders, boom. And then on the second one, it's going to be 1. Look at that. Amazing, absolutely freaking amazing. Ah, fuck, shit, fuck, damn. Okay, so shaders, and then it's gonna be size of shaders divided by size of shaders 0. There we go, so it should be alright. Hopefully now it will compile. Almost. So it didn't like, yeah, semicolon, another one. Okay, looks cool. So if I try to run it, it seems to be working, it seems to be twerking. Right. So now we're capable of actually adding several shaders. Right, we can now add more than one. Okay, so let's go to the free glyph renderer. So free glyph renderer is located somewhere here, and as you can see, we have two shaders in here. I'm gonna do a very interesting thing. I'm gonna add the third one. This is the third shader. Okay, and we're gonna try to compile the third shader. So how do we compile shaders? So extra compile shader. Right, so we're gonna provide the source, the path to the source code. I think it is located somewhere in the assets, right? Maybe shaders or something like that. Shaders, and this is gonna be reusable GLSL. The shader type is going to be, let's say, vertex shader, and the output is going to be redirected to the shaders 2, right? And if this entire thing has failed, right, we are supposed to return 1. There we go. So now we're linking everything with the third shader, and moreover, we actually have two vertex shaders. I never knew if it is possible at all or not, and I'm literally learning that right now in front of your eyes. Like, I'm doing something that I don't know about the GLSL, right? What's up? Hi. So yeah, let's see if we can actually link more than one vertex shader into the mix. Alright, so let me see. So everything seems to be compiling, and it is fine. I don't see any problems in here, so it is working, it is twerking. And if I try to introduce a compilation error in here, it will not compile, so it just basically allows you to do this kind of shit. That's actually pretty cool. Okay, so, and in here, I can now try to go to the fragment shader, so free glyph fragment, right? So this is a free glyph fragment, and I'm gonna try to essentially use GL frag color. It's gonna be vec4 f uv. So we do have uv in here. It's gonna be 0 0. Right. So this is gonna be 1. And if I try to compile this entire thing and run. It will not compile because there's no such function called f. Right, but now if I do something like this in here, right, and I try to run it, it is working, but it does not allow me to use that because the shader is compiled as the vertex shader. You see? This is actually really interesting. So this kind of confirms my my theory. We compiled reusable as a vertex shader, but we're trying to use the function from the reusable from the fragment shader, and it does not allow us to do that. If we change this thing into the fragment, I suppose we'll be able to use that in a fragment shader. So that means if you have a module that needs to be reused from both fragment shader and vertex shader, you have to compile two versions of the same shader. That's actually very interesting. Is it even possible to know at the time of the compilation of the shader what kind of shader you're compiling? Are you compiling it as a fragment shader or vertex shader? There should be some macros that allow you to do that, so you can adjust your code to be in vertex or to be in fragment shader. And I do remember something like that when I was watching the refterm demo by Casey, right? So Simura Tori, so he was using DirectX. I know nothing about DirectX, but he said that the shader that they're using, right? So GLSL shader can act both as the vertex shader or the fragment shader. And I wondered if that's achieved by basically compiling it as vertex or fragment. I don't know how DirectX works, but yeah, it kind of sounds familiar, if you know what I'm talking about. So yeah, and the talk that I'm talking about is actually, I think it was the first demo. Ref term version 1, I suppose. Yeah, and it's impossible to even find it on YouTube. Okay, and made here. Okay, so can I go to the Molly Rocket? I should be able to. So yeah, I was talking about this one, I suppose. For some reason, YouTube doesn't allow me to actually do it. All right. So, and let's go to the description. And yeah, ref term version 1 demo. So I was talking about this one. PhD terminal works, yeah. So I was talking about this one. Anyway, so if I change it to the fragment shader, right, and we can try to recompile this entire thing, will it even work? So this is going to be that, and it is working. Yes, you can reuse the code by just linking with this code. This is actually pretty cool. I didn't know that you can do that. Yep, you can move all of your functions, like some functions that you want to be able to reuse, to a separate shader, compile that shader and just link it into the main program, and it's going to be available as long as you forward declare these functions. So yeah, that's pretty cool. So you can have a reusable code in here. This is amazing. Yeah, but you have to compile it as the corresponding type of the shader. So if you have functions in a vertex shader that is compiled as vertex shader, but you're trying to access them from a fragment shader, you won't be able to do that. So they sort of have separate linking names. It seems like it. I never read anything about the GLSL and how its linking process works, but I just ran a couple of experiments, and that's what I can see in here. That's pretty cool. I really like that. So that means the thing we can do now is, for instance, we can move everything related to the camera and mapping of the camera and stuff like that to a separate GLSL module and reuse across all of the possible programs that we can have, so we don't duplicate too much code. See what I'm talking about? I think that's pretty cool. I really like this. I didn't know that, so I still don't know a lot of things about OpenGL, so I'm still learning. So I just learned about this fact right on the stream. Right on the streamers. So, how are you guys doing, by the way? So, does anyone work with OpenGL professionally here? So you have to compile it for every shader. I suppose you have to compile it for every shader type and also for every shader program, right? So it just depends on what you mean by word shader, right? Because in terms of the OpenGL, there is shader program, there's a shader, and there's a shader type. So what do you mean by word shader in your message, right? So you mean a shader program? You mean shader? Or do you mean shader type? These are three different things, completely different things, in terms of the OpenGL, in terminology of OpenGL. So I suppose you need to do that for each shader type, right? I think, right? Because the functions and symbols, I suppose functions, I'm not sure if it's symbols, that are compiled as fragment shaders are not available from vertex shaders and geometry shaders, I presume. I never worked with geometry shaders. It will be kind of interesting to work with geometry shaders. Maybe we're gonna do a stream where I learn geometry shaders. Or maybe I won't. This channel is dead anyway, so nobody gives a shit. Maybe I'm gonna do that on my own spare time. So so what I'm thinking is that we can start work of moving everything related to the camera to separate modules and refactoring everything so the camera stuff is, you know, reused for the cursor program as well. Yes, kawaii freaking yes. But we were gonna do that. I think I want to make a small break and I want to make another cup of tea because I ran out of my tea. So let's just. Okay, let's continue. So what I want you to do, I want you to extract everything related to the camera to a separate unit or translation unit. Maybe we can call it translation unit, why not? So I'm gonna call it camera, right? So this is gonna be GLSL, and I'm gonna remove this thing. And so in the free glyph, right, we have camera project, right? So, and interestingly enough, oof, this one is interesting. Can I actually refer to uniforms in there? It would be kind of cool if I could. Alright, and specifically in here I could refer to the camera resolution and stuff like that. Yeah, I could actually copy this entire thing. Right, and then, so this is the camera scale and so on and so forth. Alright, so I want to remove the camera project and just use this thing. There we go, we have a vert shader. To be fair, the camera is usually related to the vertex stuff, so I might as well just call it vert, right? I might as well call it vert. So, and then, so this is the free glyph. In the tile glyph, I think we're using pretty much similar setup, so I can just put it like that. Right, so this is going to be camera point, and in the cursor, yeah, so we also have a camera project. I can put it like that. There we go. Camera. What is camera project? Yeah, it was a camera project. There we go. Camera project. There we go. So that camera project, camera project, and tile project point. Okay, so might as well just do something like this. Camera project. There we go. Cool. So let's try to compile this entire thing and see if it runs or not, and how it runs, and everything. You know, the usual stuff. So if I try to run this, couldn't find. Okay, so there's no such thing as reusable. Reusable GLSL. So this one is supposed to be the camera, right? Camera GLSL. Interestingly, what if you have like several different lists of compiled shaders and you want to concatenate them? Maybe it would be nice to have a separate function called attached shaders to program, right? So that's actually a pretty interesting idea in my opinion. So you link program, you compile a shader file and so on and so forth, and you can have something like void attach shaders to program, right? And in here you essentially accept this thing and the program, and that way if you have two lists of the shaders, you can sort of concatenate them by keep attaching them. ANJKYKS, thank you so much for 7 months of tier 1 subscription. Thank you, and welcome to our epic OpenGL club. How about that? Thank you. Alright, so attach shaders to the program. Yeah, because you may have a list of the vertex and fragment, right? Vertex and fragment, and list of everything that is shared, sort of like list of core shaders. And you can sort of pre-compile them and keep it separately. And then as you compile a new program, you always link it with those shaders as well. So I think that's a pretty good idea, right? And then linking in the program will not accept any shaders. That's a good idea, actually. Like you separate attaching shaders from linking shaders, and soon these functions will become redundant completely because we will go down to direct OpenGL calls. All right. It's kind of interesting. The OpenGL commands are really verbose, right? And you want to group them into higher level functions. But as your program grows in complexity and you start to have more and more different use cases, you start to appreciate its verbosity, because it's sort of like designed for a lot of different use cases and a lot of different ways of organizing your code and your data. And sort of as your code organization grows, this sort of verbosity makes it really flexible, if you know what I mean. It's kind of interesting. Like you don't appreciate it when you only start learning OpenGL, but as you learn more, you start to realize, oh, that's actually really clever. Okay, so separating the attachment allows you to just basically concatenate the list of the shaders really easily. Yeah. What will be special about that editor? Nothing. Unless it's the same too, OpenGL seems to be granular at just a perfect level. Yeah, it's actually really interesting. It's actually really interesting. So and what's interesting is that as your program, initially your program is actually very simple, and you can create these blobs of functions, right? That have a lot of OpenGL calls. And as it becomes bigger, you can take those blob functions and start separating them, right, as you need, right? For example, here, I always attach shaders in the link program. Now, I feel like it's not really convenient, so the attachment of the shaders moves out of the link program, and the functions start to sort of like split, right? They start to divide like cells, right? So, and becomes more and more granular as you need, so you can basically control the granularity of this entire thing as you go. This is actually very interesting. Okay. And it's also pretty good exercise in controlling complexity. Alright, so maybe I'm gonna just introduce this function in here, right? There we go. So, and also we delete the shaders. I'm not sure if I want to delete them. Right, so deleting shaders here is also not a particularly great option. Deleting shaders at all in this program is not really needed because we don't even have a hot reloading for the shaders, so it's kind of pointless. Right, so here we are attaching the program. So attach the shaders should not accept the program by a pointer. In my humble opinion. So yes. Oh, and in here, if we're gonna be attaching programs separately, yeah, this one is gonna be really interesting. So I'll have to move. I almost completely separated everything. What the fuck? Attach shaders to programs. So here is the shaders and stuff like that. So this is just the stuff. And I suppose maybe in here, yeah, we'll have to probably create the program outside. Yeah, let's actually create the outside. So here we're also going to accept this thing. So this thing will automatically link the program and also check if the program like is okay. And by default in here, what do we even do? What was the... Wait, what? This is so weird. This entire shit worked accidentally, completely. Okay. I see. So this one is supposed to be false and this one is supposed to be true. Okay, so as usual, I have a code that just worked accidentally. Classic. Though I can probably just return the linked, right? And that's gonna be fine. And that's gonna be fine. So here's the link program, then we attach the shaders. And let's go through the process of compiler-assisted refactoring. What do we have in here? So this one is a program, so we just attached everything. Alright, so link program. It conflicts with whatever stuff we have in there, right? With whatever stuff we have in here. What else do we have? Okay, so now we go in here. Get program IV. Anything else? Link program. So what does it complain about? Yeah, so since this entire thing doesn't really attach the shaders, we can just put it like that then. glextra.h, right. Okay. Okay. So here we're compiling the shaders. All right. We're compiling the shaders. Then I need to create the program. GL create program. Right. Docs.gl. GL create program. GL2. Gel. Okay. Here's the program, and then we do attach shaders to program. Shaders size of, I might as well actually copy paste this entire thing in here, and then the program, right? And then I'm just linking the program. Just linking the program. Okay, so the program didn't link. We're gonna actually exit. So I don't see any need to split that thing yet. But we may need maybe a function that accepts a list of files and their corresponding types and just compiles everything at once. That could be a thing that we want to do. We'll see. All right, so I'm just attaching everything in here. So I need to go through all of the places where we do all of that. So yeah, so here is another place. Attach shaders to program. First we need to create the program. Well, we have to create it assigning to here. Oh, by the way, in the previous one, where did we do all of that? So this is a tile glyph. I need to remove tile glyph. I think we're not gonna use the tile glyph renderer anymore. Like, at least I didn't see any point in having it. Right, so we're only gonna have like a free glyph renderer. Yeah, so at some point we're gonna do that. Maybe after I'm done with the refactoring of this thing, I'm gonna just simply remove the tile glyph renderer. GL create program, right, GL create program, and attach all this stuff. FGB program. Hello, Soda Todo. Soda Todo. Nice nickname, by the way. It's like it's almost like Lemon Demon. Alright, so this is going to be attaching the shaders, and here's where we're attaching the shaders. Right. Alright, so FGB program, so passing the argument, and I'm not quite sure, so I think the program has to be here, FGB program, there we go. So that's what's supposed to be in here, right? So now we have a CR program, which is the program for the cursor, GL create program, right, so we're just creating the program. Attach shaders to the program, CR program. Here are the shaders. And then we're just linking the program. As easy as that. Cool. So of course this entire thing has to be like this. Okay. Everything seems to be compiling, so let's actually see if it still works. It cannot read no such... Oh, because the file is actually called not GLSL, right? It's specifically vert, right? It is specifically vert. Okay, so and if I try to run this thing now, it's still unresolved reference, but in which file? Okay, this one is very interesting. Linking, oh shit, we really need to know where exactly that shit happened. Okay, So linking error. Linking error. One thing I can think of, by the way, one thing I can think of is when you're trying to link, right? We can also provide the location, right? So you can provide the file path and the line, right? And now in the GL extra, we're gonna do the following thing. Program linking, we can provide the file path and the location. So this one has to be something like this, and I'm gonna go to here, right? And I'm gonna provide file path and the line, right? And of course I will have to actually modify a couple of places in here, but that's fine. This is gonna be file line. Another one is going to be file line, file line, and let's go. Alright, so if I now try to run this entire thing, it tells precisely it fails in the freeglyph.c. So that's actually a pretty convenient way of doing that, because in case of a linking, there is no shader file. All of the shader files compiled correctly, right? But when you link in, like you don't know where exactly. So we can actually report the place in the source code where it failed, right? So, and we know now that this thing failed in the camera, in the freeglyph project, right? We can even try to run this thing from within the Emacs, and we can jump precisely to this specific place where the linking of the program has failed. So this is a pretty convenient trick in my opinion. So usually it's done with macros and stuff like that, but I don't want to wrap it into a macro. I don't think it makes sense. I don't think it makes sense. Alright. I'm pretty sure that this text editor will support Vim key bindings by default. Why are you sure about that? Tell me all of your feelings. I'm really interested. Okay, so let's try to understand why this kind of shit has happened. So it's gonna be camera, something like this. It's kind of strange. Alright, so freeglyph. Freeglyph dot vert. Right, so here it is. It should be visible, but I don't quite understand why it couldn't see it. Right, why? We just conducted an experiment. Oh, because it's a fragment shader. That's right. Right, and we have to rebuild everything. Kidding. That's a very funny joke. Thank you so much. I really appreciate your sense of humor. It's actually super fucking funny. Alright, so let me see. So glyph program unresolved F. Okay, so and where I'm trying to use the F function, so I need to Cheesty Code. Thank you so much for 2 months of tier 1 tier 1 subscription. Thank you, and welcome to our epic OpenGL club. Alright, so we have F, and I think I'm just gonna discard this entire thing. I'm just gonna discard that and that and that. And alright, unresolved reference to camera project for the cursor render. Okay, so now we are starting to, you know, to work with the real stuff. Right. So this one is going to be vertex, right? So the vertex shader. So this is going to be the second one, and shaders, camera vert, right? Shaders camera vert, and okay, and resolve reference to camera renderer. Oh, this is because I probably have to do GLSL. I have to go here. All right. Okay. And now look at that. So now both cursor and the text synchronized to the zoom, right? So everything is synchronized to the zoom, and this is because we're sharing the camera projection between the cursor program and the glyph program, right? So that's pretty pogue, I think. I think that's pretty pogue. And again, we can probably so where's the vert? Right, we can probably speed the entire thing up, so to make it like a hardcore mode. Right, so, and you need to try to edit your text like this. Can you edit the text like this? I don't know, it's kind of hard, not gonna lie, but... epilepsy warning, by the way, so yeah, I'm really sorry. Is this the text editor you're working on now? No. Alright, so if I'm gonna do something like this, so 1, 2, 3, 4. This is actually way too dank. The fuck, this is the dankest shit I've ever seen. Holy shit, this is so cool. Nice. Cool. So we're gonna remove this kind of thing. Okay, so we have a camera scale and whatnot. Nice. Alright, tile glyph and shit. So we probably need to do a committee. Maybe even push. So what did we do in here? Wait a second, so we cleaned up, so this is a completely different thing. Add scale to the camera. Right. So that's basically what we did. I'm gonna push that right to the repo. So if I try to... Maybe we also need to add the ability to hot reload the shaders and stuff like that, because, yeah, maybe I want to play with some concepts without reloading everything and stuff like that, so I don't even know. Yeah. Alright, so we're gonna push that and yeah. So one thing I want you to do, I want you to get rid of the tile renderer. Right, the tile renderer is kind of obsolete. Tile renderer. I can try to enable the tile renderer and I don't even know if it still works or not. So it's kind of like behind the feature flag. Right, so let's try to compile this thing with a specific feature flag. Is it still compilable? It should be still compilable, I think. So it's compilable, but if I try to run it, it doesn't even, yeah, it doesn't even run properly. But I think this is because we don't really link things appropriately. So let's actually try to fix the tile glyph renderer. So the tile glyph, does it even store its own program? It doesn't really do that, but who cares? Alright, so we're gonna have 3 in here. So here's the 3 shaders. 3 hot shaders. So it's gonna be compile shader file, and it's gonna be shaders camera GLSL. So here we have a GL vertex shader. This is gonna be the shader 2. Right, and if it didn't compile, we're just gonna do 1. Alright, I think that should work. Right, I think that should work. So shaders. Fuck, because it's not GLSL, okay. Okay, so this is the legacy renderer. So it's a sort of like a monospace legacy tile renderer, and I kind of low-key want to remove it. So let's think, is this renderer even needed? Right. Because it's like basically rendering from this bitmap font that looks like this, And in my opinion, TTF fonts are way better, and I'm pretty sure you can come up with a TTF font that looks like this, right? So I think it's kind of redundant to support these like two separate renderers, and they're like fundamentally different as well. They're completely fundamentally different. So I think I'm gonna just go ahead and remove this entire thing. So yeah. So if we take a look at the you know, the free glyph renderer, right? This one is a little bit better, right? This one, like, you can use whatever font you want in here, right? So if, for instance, you want a Comic Sans, right? So let's take a look at FC list, and I want to grab -i comic, right? So let me see. Regular, so here's the regular one, right? And I'm gonna just copy this entire thing in here. So here's the regular. Do I have well, I mean, I probably need to copy paste this properly. So it's gonna be src main ttf, yeah. Comic new regular, so you can just assign this thing in here. Recompile the entire stuff. And let's go. So you can now code with Comic Sans if you want to. I think that's pretty cool. So you can open the text, the source code of the text editor within the text editor, and there you go. Here's your stuff. Here's your stuff. That's pretty cool. What do you guys think? Isn't that epic? I think it's pretty epic. So, and because of that, I want to remove the tile renderer. Right? So the tile renderer is not removed. Okay, so it's gonna be tile. Yep. And the way we're gonna do that, I suppose I'm gonna just straight up remove these two files and just try to compile it. So it also probably will make sense to compile it with tile renderer, right? Okay, so in the build, tile glyph renderer, right? So here is the tile glyph renderer. I'm gonna remove that thing, and let's try to recompile. Okay, so we don't have that. So tile glyph, render cursor. So this entire thing is not needed anymore, I suppose. Yeah. So I'm just removing a bunch of code. Removing a bunch of code. So we're only gonna have a free glyph renderer. Is that it? Looks like it. Okay. Tile glyph, so we don't need that stuff anymore. Okay. Alright, I think that is it, and we removed everything related to the tile glyph rendering. Yep. So we sort of slowly transitioned from tile glyph rendering to the free type rendering. First thing we did, we separated that into like separate entity, then added a similar entity for free glyph renderer, and then we removed the original one. So sort of slowly migrated from one thing to another. Okay, remove legacy tile. Wait. So there's another thing. This thing dependent on this file, right? So we can just easily remove the entire thing. So right. So there's no need for this sprite sheet anymore. Okay, remove legacy tile glyph renderer, and I'm gonna push that right into the repo. Right, less legacy code. Okay, so we have an ability to sort of scale things around. Well, not really, actually. Right, so we depend on this camera value. So I want to actually get the camera scale from the uniform, right? I want to get it from the uniform. To do that, right, in the renderers, in the corresponding renderers, I'll need to add another uniform, right? So free glyph. All right, so here's a free glyph uniform. So we have a camera uniform, and we need to add camera uniform, not really uniform, camera scale uniform. You know what, like for these kind of uniforms, I really want to have some sort of like a enumeration, if you know what I'm talking about. So it's easier to sort of communicate what kind of uniforms we even expect, right, from the programs. It would be like really nice to have something like that. So right now we have time uniform, resolution uniform, camera position uniform, and camera scale, right? And we could do a usual trick of type def enumeration, uniforms, just like, yeah, uniforms, and then uniform time. Here's your resolution, here's your camera position, here's your camera scale, right, so scale, and then you can have something like, so the first one is obviously 0, then do count uniforms, right, and then instead of this kind of thing, we could say, so we were going to completely remove this entire stuff, uniforms GLint count uniforms, right? So, and you can refer to these things by their corresponding index in here, right? And initializing all of that should be relatively easy. So we can also have something like type def struct uniform definition, right? So we have a uniform definition, right? So this one could be uniform, maybe kind. To be fair, it's just it's a specific uniform. It's not really uniform kind. So uniform definition, so it could be uniforms. I'm still not sure how we're gonna call that. It's a uniform slot? Could be slot, why not? Right. Slot. Slot count uniform slots. And this is the slot. And in here, we could have in the definition the name of this entire thing, and maybe also the type, right? Maybe also the type. And the type of that uniform could be something like, ooh, I don't know. I'm not sure if type is really that important, but it could be important in the future, I suppose. Right. So should be fine. And then we can have a function const uniform definition, get uniform definition, uniform slot, right? And then if you want to get the specific definition, you can just query it like that, and so on and so forth, just to know the name of it. Yeah. Count uniform slots. Right, and this is the uniforms that are expected from all of the programs, right? So each program should have an access to the current time, to the current resolution, to the current camera position, to the current camera scale, and so on and so forth. And this is basically becomes some sort of like a registry of all of the uniforms. Yeah, so something like that. I don't know. Does it sound reasonable? Sound reasonable? Like, I find it super convenient to use enumerations to keep track of different OpenGL entities, right? So, different OpenGL entities like that. I think it is pretty convenient. How do you track your OpenGL entities in your code? Right. I constantly use enumerations for like tracking these kind of things. I also use enumerations for vertex attributes, right? So for each vertex attribute, I have like separate entry in enumeration, and yeah, I have like a list, like a definition of these things. right? So here is the definition for each individual vertex attribute that is then used to initialize everything appropriately and stuff like that. Leave your comments under the video. Exactly. Exactly. Alrighty. Yeah. So I think like working with OpenGL should be a little bit more convenient in languages like Pascal, where enumerations are a little bit better. But there is not that much good OpenGL support in Pascal. I actually tried OpenGL support in free Pascal, I think at some point. I don't remember. I think I had like a project somewhere. So it's free Pascal. Yeah, free Pascal OpenGL shaders. Yeah, it's here. If you're interested, you can find it in here. Alright, and of course for people on YouTube, I'm gonna put this entire thing in the description. So OpenGL shaders in free Pascal. And I think I do have it cloned somewhere. Free, yeah, there we go. So so this is gonna be pass. Yeah, sure. Yeah, here we go. So I have shaders in here, like baked into the Pascal, right? And if I try to run this entire program, yeah, this is written in Pascal, by the way. Hello, Cybercyclonic. Yep. So this is a Pascal OpenGL application. So it is possible to use OpenGL within Pascal, and free Pascal specifically has a built-in support for OpenGL. It's relatively convenient, so you just install free Pascal distribution and it already has GL extension, GLUT, math was always like a free Pascal thing, not only free Pascal. So, and yeah, that's pretty convenient. It's pretty cool. Pretty cool. But I didn't really use any Pascal enumerations in here because I didn't really do anything super complicated anyway. But it would be interesting. So if I had like a complicated vertex attribute, right? Generic vertex attribute that consists of like 10 different entries, right? How convenient would it be to do that in Pascal with Pascal enumerations? Don't know. We'll see. We'll see. Math. Well, I mean, I needed a module for mathematical stuff, but the word math was already taken by the standard library of Pascal, so I had to come up with a different name, so it was called math. Math and math. So, and in that module, I remember what I kept. I think I kept implementation for vectors and triangles and stuff like that. So, things like this. Nothing particularly special. So yeah. Interesting. Pascal. Pascal has a yellowish color, which you rarely see on GitHub because nobody programs in Pascal. Right. I think I'm the last person who programs in Pascal, unironically. And I kind of like this language. I think. Yeah, I think it's pretty cool. So the original Pascal would have been a great candidate for C killer, in my opinion. Anyway, whatever, let's continue working on C stuff. Who cares about Pascal? It's a dead language anyway. It's a dead language. So what I wanted to introduce, like enumeration for uniforms, and maybe I'm gonna even create a separate unit, something like uniforms. So we have GL extra stuff, free uniforms, right? So yeah, let's literally call it uniforms. Uniforms.h. It's a really shame that Pascal got into educational system, and now a lot of programmers like have a bad association with that language because of shitty teachers. The thing that people teach in Pascal in universities and schools, specifically in Eastern Europe and Russia and stuff like that, like it's not even showing the full potential of that language. It's actually pretty shitty. This language is capable of so much more, and it's never shown, unfortunately. Teach algorithm with a custom and bad spin of Pascal. Yeah, so interestingly enough, like the idea of having a separate educational programming language doesn't really seem to be working that well, because not that many people are capable of separating the programming concepts from programming language. That's what I found actually while talking to other people, to other programmers. A lot of people just incapable of separating the language itself from programming in general, right? So, and it's difficult for them to transfer their knowledge to a different language for some reason. And because of that, like if you have educational language, right, people come out of the universities and they cannot find a job because they don't realize that their knowledge translates to a different language and they think they don't know the language or something like that. It's just like really strange, like, because for me it's not that difficult to do that. It's just like, yeah, it's the same thing. All the languages are the same shit for me. And I don't really understand why people think that way. Maybe my brain is weird, I don't know. Anyway, so the idea of having a separate programming language specifically for education doesn't really work out that well. So, but at the same time, the languages that are used in the industry are constantly switching and changing. But I would argue that it's a problem of industry rather than educational system. Anyway, whatever. So it's not defined, it's going to be end if. This is why we can take people with the mathematics background, because they can separate the two. Interesting. That's a very interesting approach. I wonder if you can teach that separation as well. Maybe this is something that is teachable, right? So essentially you teach one language and then you teach the second language and you're constantly showing them, look, two things, the same shit. Look, they're the same. It's just like only syntax that is different, but they're the same. So your knowledge translates to another thing. Look, here's the third thing. Look. Syntax different, but it's the same thing. Knowledge translates. Maybe it's something that you have to teach people separately, right? And maybe this is something that universities should also do. Some of them try to do that, but I think a lot of them should try, like, specifically point out, look, just because you know this thing doesn't mean that you don't know this thing. You can still do that in there, right? So it's a teachable, but educational system doesn't care about it. I guess maybe. The everything is a memory model really removed the ability to recognize patterns. I'm not sure what you mean by that. Alright, so here's the uniforms, and I want to move this kind of stuff. From dev. Alright, so we're gonna keep this stuff in here. And I'm going to create uniform.c. Alright, so I'm gonna include this entire thing. Uniform.h. I think this is something that comes with experience. Yeah, but this fact doesn't solve any problems, right? The industry needs the people who can recognize, who can separate the language from the programming concepts. And educational system just fails to produce such people, right? The fact that it comes from experience doesn't really solve anything. Okay, sure, but what do we do now? It comes from experience. How do we solve the problem? I don't know. Uniform def, uniform defs. So this one is going to be static, right? And this one also going to be const. So, and essentially here I probably want to do the assertion, assert h. So I'm going to do the boundary check, the coveted boundary check. Hi, how is the text editor coming along? Well, it's like Billy Harrington. It's fucking coming along. In Russia, we all want to learn JavaScript and earn much money doing React. Thank you, comrade, for sharing our Russian secrets to everyone. Aren't Russian basically programming in only in one C or one S or whatever the fuck is that supposed to be pronounced in English? I don't know. So I didn't know the Russians know any other languages. I thought they only program in this thing. Right. I don't know. 1S. All right. So, and what I want to do in here is going to be slot less than count uniform slots, and we're going to return uniform defs slot, and we're gonna just take a pointer to it. There we go. Boundary check. Unfortunately, we're not programming in Rust where this kind of boundary checks are generated for you automatically, so we have to do that manually. Unsafe languages, Pepper Hands. I've been learning programming for 2 years. After 8-11 months, I had most of the programming concept just by switching languages. Yours is a great idea. Cool. How many languages do you know? Or you don't need to know any because you copy-paste from Stack Overflow. 69, nice. What we're gonna have in here is gonna be free glyph.c. So yeah, here's the interesting thing. So we want to do FGB. We just want to get the uniform locations, right? 1C salaries is considered not so big. Everyone wants to learn Python and JavaScript. There are expensive courses that teach these languages, but people can't find a job after them. Cool. Russia is a weird place, actually. I hear a lot of weird stories from Russia about software development in there. I don't know. Feels like being a software developer in Russia is really tough. I'm not gonna lie. Good thing we're not in Russia. Yes, good thing we're not in Russia. I don't know if I will be able to even be employed in Russia. If I were Russian, I would pretty much be unemployed. Hit Kona! Hey, Lee, brother, keep Kona! The land of freedom always providing enough programming jobs. Hey, Lee. So, let's actually go through the compilation errors and stuff like that. It's gonna be build.sh. Count uniform slots. Right, so we're gonna include uniforms.h. I suppose this one has to be something like uniforms. Uniform slot, yeah, uniform slot resolution. There we go. So this is how we update that. You want to see a little bit about Emacs magic? Look, look, boom, boom, uniform slot, boom, boom. Can your Vim do that? I don't think so. I actually don't think so. I can go. It is in fact pretty much a go. What else do we have in here? Uniform slot camera. Oh, it's supposed to be camera position actually. So, 1K. Yeah. So, well, you can farm it if you want. So, this one is rather interesting. So, oh, here is actually pretty cool. So now I can simply iterate. Right, I can simply iterate through all of the uniforms. Yeah, you can farm it as commits. Uniform slot, starting from 0, slot less than count uniform slots plus slot. Right, and in here is going to be FGB uniforms slot equal GL get uniform location FGB program. And here we'll have to do a special thing, right? So we'll need to get the uniform definition. So it's going to be uniform definition get uniform definition by a slot. There we go. And then I can do def basically name. There we go. And we don't need any of this shit. Right. So this is how we initialize all of the uniforms. And I'm thinking that this entire thing could be actually extracted into a separate function within the uniforms themselves, right? So we can have something like get uniform locations, right? And here you would accept GLUint locations, and this could be actually an array of the size of count uniform slots. This doesn't really pass the array by value. It will still decay to a pointer, right? It will still decay to a pointer, but it sort of documents the entire process, right? It sort of documents that you expect an array of this specific size in here, right? So, and we also need to accept the program. Can't wait for dead necromancy. It's gonna happen when the project dies and somebody will try to pick it up and revive it. So in that case, we can call it a dead necromancy. Aha! Oh. Sorry. And it will die eventually, trust me. I have no plans to maintain this piece of shit. So, yeah. It is what it is. Why are you weirding me? Why are you weirding me? It's gonna die and somebody else will try to revive it because it's cool. And it's just the cycle repeats itself. And then they will abandon that project and then somebody else will try to revive it and I don't know. Pepper hands. Pepper hands. Alright. Alright. What's up, Pog boy? How are you doing, my comrade? Welcome. Uniform slot 0 slot less than count uniform slots. You're good. How I am? I don't know, just going crazy as usual. Literally. So what do we have to do in here? So it's going to be location for a particular slot, and in here we can do GL get uniform location. We have to provide the program, and then we can get the uniform definition. Right, so uniform defs and just the name of this entire thing. Okay. Uniform.h. Okay, that's cool. Hey, Mr. Streamer, will your editor support some Emacs magic? Yes. So let's go ahead and do this thing. So here are the uniforms. So this is going to be something like that. So then we're going to take something like this. It's going to be slot. No, it's going to be just slot like this. And then we're going to have a name. And the name is going to be simply this. And boom. I can do that twice, I suppose, but I mean, here we fucked it up a little bit. There we go. So here are effectively the names of the uniforms and shit. What else do you recommend for coding? Yeah, TempleOS. I think TempleOS is actually quite great. Dragonfly BSD, the problem with Dragonfly BSD is that it doesn't have, its C library doesn't have error no location up until certain version of the kernel. And I actually feel really sad that I know this small little fact. Why the fuck do I know that? Yeah. Up until which version? Dragonfly BSD. Yeah. So this one little fact I know is that up until, I guess, 2019, the standard C library of Dragonfly BSD didn't have a function error no location. Yeah. Why do I know that? I have no idea. I've been looking into the Rust code for too long, and the Rust code started to look at me back, and that's how I gained that knowledge. Just update your OS, exactly. Just update your OS. Okay, so undefined reference get uniform. So we don't really need this thing anymore, because now what I can do, right, I can call this function. Right, I can provide the FGB program, and then I can do FGB uniforms. There we go. And that will automatically get all of the locations of the uniforms. Just get all of the locations of the uniforms. Maybe at some point we're also going to implement a thing that like just updates all of the uniforms at once, right? So just updates all of them. I don't know. And another thing we can do in the uniforms, right, is a static assert, right? Classical static assert. Static assert count uniform slots has to be 0. The amount of the shader uniforms have changed. Please update the definition table accordingly. There we go. So I think it's going to be useful. So as we add a new uniform in here, we'll have to go through all the places and just update everything and so on and so forth. And I'm not sure if we need to be able to get this thing, but I'm going to keep it anyway. So src uniform.c. Pointer uniform differ in signness, signetness, signetness. What was that supposed to be? Sinus. Oh, I think I know, because uniforms can be actually signed, right? Free glyphs. Where is it? Yeah. So uniforms are allowed to be negative. Who knows why? Who knows why they're allowed to be negative? It's because it can be missing. And if it's missing, it will become -1, I think, or something negative, right? And if you pass a negative uniform to functions that set the location of the uniform, nothing will happen, right? Sort of like to suppress any potential errors if you don't have a uniform, right? They're pessimists. Well, I suppose this is because uniforms are such a dynamic thing, so you constantly add them, you constantly remove them, so it's kind of annoying that, like, if you remove something, it just, like, tells you, please update. But I kind of would like to have that, and that's why I built this system of enumerations that check for all of the uniforms and stuff like that. Will you have a day where you teach or work with C#? I know nothing about C#, so how am I supposed to teach about something that I don't even know myself? I only know GLSL. That's the only language that I know, I'm sorry. I don't know any other languages. So they didn't teach me that in university. Alright, so let's try to compile this thing one more time. So uniforms, and that means the function itself, right? Get uniform location, uniforms.h, right? So it has to also accept this thing. I don't know. So it should be called uniforms, I think. Uniform. Oh yeah, that's really strange. Nice one. Okay. Peperba, truly Peperba. Okay, let's try to do something like this. Uniform S. Okay, and let me see. Okay, so this does not compile. Oh shit, and we have to also include all of that stuff related to OpenGL and whatnot. Let's quickly do that. I really want to refactor this into a single compilation unit. You know what I'm talking about? Have you guys heard about it? Because with a single compilation unit, I won't have to, like, do this thing, like, everywhere. So, and it will compile hopefully faster. I'm not sure. Yeah. Single compilation unit. So if you're watching this on YouTube, you can find it in the description. So, right. So everything I write into this little file will be available in the description on the YouTube channel when I upload the VOD in there. So for people who are watching on Twitch, you can find this channel in here if you're interested. Right. So majority of the VODs get uploaded on the YouTube channel. Location, get uniform location. So this thing has to be signed one. This thing has to be signed one. Okay, so this is going to be slot. Has to be slot. All right. What about minority? Representation of minorities is important. Okay, so we have that, and we can try to run this entire thing now. Is it gonna work? Oh, wait, could not load file comic. Oh, because we don't have that file anymore. So let's actually go to here, and it's gonna be ttf, and let's comment it out. Maybe I'm gonna even remove this entire thing. So would that compilation be? I don't know. It's just a single compilation unit. You just take your entire source code and concatenate it and compile it as a single translation unit. So that's what it is. If that's what you mean by compiled headers, maybe that's what you mean by compiled headers. I don't know. So what do we have in here? I cannot read that. Compacted, promoted, compacted, promoted. So it's basically silently doesn't work. Vector shader. I don't see any problems in here. Everything seems to be fine to me at least. I think one of the things we can try to do is go to the cursor renderer, right? So this is going to be the cursor renderer, and we'll have to include the uniforms in here. Oh shit, what if we have uniforms? So we have a position, the camera. Oh shit, this one is actually, yeah. So the uniforms, we can actually have like a global uniform thing, like a global uniform thing for everything, and this is what we're gonna put in there, right? So this is gonna be the camera position, and for the uniforms, right, so cursor position, right, uniform slot cursor position. Another one is gonna be, what is the pose? Does anyone remember? Position looks like, yeah, it's a cursor position. Okay. Height. Suppose cursor height. Uniform slot. Cursor height. And then uniform slot last stroke. There we go. So these are the things that we're going to be passing to the shaders all the time, right? That's what we need to pass all the time. Let's try to compile this entire stuff. So this thing. So let's add the rest of the definitions for the uniforms. So this one is a slot, but then I need to take this entire thing. Put it like that, and this one is going to be name. Slot camera position, so this is going to be that. Cool. So now we have these definitions. So +3, that means this one has to be 7. Right, we defined all of these things in here, hopefully. Alright, so everything looks okay. Now in the cursor renderer, instead of these uniforms, I'm gonna just say uniforms, count uniform slots, and there we go. So we just store them as the array. It would be really interesting to try to manage several uniform slots, like uniform slot sets, if you know what I'm talking about. So uniforms for the camera, uniforms for the cursor, and somehow just merge them together, right? And you know, do something here. I don't even know how can you merge them together. But that will be interesting to actually explore. But for now, I think we're gonna just have a global list of these things. Okay, so here we just set the entire thing. Right, so this is gonna be uniform set, uniform slot resolution, uniforms, uniform slot. I think I haven't showed the text editor for too long. People are getting bored. Let me just a second. Let me just recompile everything. Let me just decompile everything. Just a second. Chat. Here comes the content. Here comes the content. Almost. So in the main, did I actually compile the entire thing? So it's going to be comic. Alright, here comes the content. Chat, look. You're going to be entertained soon. Are you ready to be entertained? Are you ready? Look. This is the text editor that I'm developing right now. Isn't that cool? This is literally what I'm developing right now. Look. I think it's pretty fucking cool. Do you like that? Do you like that? This is actually pretty fucking cool. right? You can even open like the source code of the editor within the text editor, right? So I know that the uniforms, the slots and stuff like that is a boring nerdy shit, and this is why I'm showing you this kind of stuff, right? So this is cool. OpenGL is fucking boring. This shit is cool. I think this is pretty cool, right? Yeah, look at that. Look at that shiny, cool thing. We can even make it dance if you want. Let's just take a look. So we have to go to the camera, right? And we just need to speed up the whole process of pulsating and stuff like that. It's going to be 16, right? So look at that. This is your text editor. It's a like hard bass text editor, so you need to listen to hard bass while editing this entire thing. So isn't that cool? I think that's pretty cool. Can you add syntax highlighting? Of course I can add syntax highlighting, my comrades. Hello, how many comrades? We already detected 44 comrades. Of course, my comrade, I'm gonna add the syntax highlighting just for you. Just for you it's gonna be implemented, but tomorrow. But tomorrow. Yes, not right now. Alright, so yeah, let's continue. So, it's gonna be that, let's remove that, and continue. So what I'm trying to do right now, I'm just trying to do a little bit of a maintenance work, so doing that a little bit easier, right? So to make it like maintain this sort of feature a little bit easier. I know it's fucking boring, I know this shit is for nerds, but it needs to be done, otherwise we're not gonna have any cool features, right? I feel like I'm explaining technical debt to my manager, like, it's kind of... That's what I feel like right now, seriously. Like, it's just like, we need to do a little bit of refactoring. It's important, right? Trust me. Otherwise, it will be kind of difficult to add cool and interesting features. So, yeah. It's almost like I'm doing programming stream, but not for programmers. So... it's kind of funny. I just personally find it funny. So, yeah, let's continue. So I have a registry of the uniforms, and I'm still not sure if like smashing all of the uniforms in a single list is a very good idea, but maybe it is not, I don't know. So let's try to compile this entire thing and go through the compilation errors and whatnot. Right, so what do we have in here? So here is the uniform slot time, right? So then we can have a uniform uniform slot camera position. There we go, here's the camera position. And we also have a height, and I'm not sure what was the height. What did I call height? Cursor height. Yeah, it is cursor height. Okay, so this is gonna be uniforms uniform slot cursor height, and this is gonna be this thing. All right, so oh, we have a lot of places where we have this weird thing, so maybe I should get rid of this. Alright, so let's go get rid of it super quick. So this one is not needed, because we already removed the tile glyph renderer, right? So it's already gone. Tile glyph renderer. So last stroke. Oh shit, that means we'll have to go through all of these things and just do something. So many people suggesting so many cool and interesting ideas. Oh my god, guys, you're so creative. Holy shit. This is so cool. So that's so fucking cool. Thank you so much for all of the idea suggestions. I'm definitely gonna implement all of them because they're so creative and interesting. Thank you so much. Yeah. So We built such a creative community. Holy shit. So last stroke. Maybe can we actually like query replace this entire thing with just simply something like uniforms slot last stroke, right? So last stroke, there we go. So it's gonna be a little bit easier to do this kind of thing now. Okay. Count uniform slots. So that means I need to include the uniforms in here. Uniforms.h. Okay, so here we're just taking all of these things. So that means I need to call the function, right, get uniform location. So the program, we do cr program and then cr uniforms. And we can remove the entire thing. Cool. So now, if I do this thing, cursor move to. So this is a cursor position, if I understand correctly. So it's going to be uniform slot cursor position. There we go. So there's several of them. It's not a single uniform, it's many of them. Okay. Let me see. So it still doesn't work. This shit still doesn't work. So let's go to the shaders themselves, right? Let's go to the shaders themselves, and I'm gonna go to the free glyph vertex. So let me see if we missed anything. So this one has to be a position, right? If I understand correctly, this one has to be a scale. Position and a scale. Is that enough? No, this is not enough. Alright, so interestingly, so I think I also have to update the camera. Yeah, in the camera, this one also becomes something like position. Right, and I'm just going to recompile just in case. Right, if I try to run it, and at least it now fails, right, and it fails somewhere in the camera. Okay, so we have a camera position, right, so we have a point, you adjust the point to the camera position, and you also scale everything, and only then you map it to the resolution. All right, so if I try to do that, it still doesn't work, right, but I still don't see any problems, at least with the free glyphs thingy, right. So it's very strange. Fragment, maybe it has to be in a fragment. So we still have time and resolution. Font is not really important, right? But we could add font to the list of the uniforms anyway. All right, so tile glyph. I think the tile glyph could be removed. I don't think we need to keep it in here. So this one is a camera position, right? We don't even need the camera position in here, so we need the cursor position, cursor height. So, but this is only for the vertex one. For the cursor fragment, we'll need last stroke, and I think that's pretty much it. So I don't think anything else is needed in here. So failed height isn't declared. Oh, okay, height, cursor height, cursor position, and then with the camera project. Still doesn't work. I'm not really sure why. I wish we had like render doc working, but it is not working right now because OBS prevents it. Maybe it's OBS, maybe it's something else, but it's just like render doc isn't capable of capturing anything. So the only option I have in here is maybe, I don't know, going through everything. It could be something with the vertex. I forgot. With the camera stuff. Alright, so I can try to test some of these things by actually like setting... Maybe not even projecting. Alright. So what if we don't project? right? So I can do something like vector2 id vector2 x, which does not even do anything. Right, and I don't need to do this thing. All right, let's make a small break. After the break, I'm going to make a cup of tea, and then we'll try to troubleshoot this entire problem. So we need to understand why exactly it just shows the black screen. All right, so... all right, let's try to debug this entire thing. Let me do the reverting back to our current things, because I was demonstrating things to the chat. Right, and let's go back to the black screen. So here's the black screen, there's nothing in there. All right, so let's go to the to where we initialize everything. So I'm gonna go to the free glyph renderer first. Get locations or something about uniform locations. Okay, this looks good. Let's breakpoint at like around here. So it's gonna be break free glyph .c, and this is a line 113. Okay, so let's run this entire thing, and let's take a look at the state of this entire thing. So FGB uniforms, right? FGB uniforms. So right now all of the uniforms are empty, and now if I take a look at the uniforms in here, okay, majority of them are actually -1, and this is in FGB, so only the first and the second one are correct. And what are the first and second one? Let's actually see. So so there should be uniforms, right? So the first one, time and resolution. But camera position and camera scale should also be available in the free type fragment. So let's take a look at the shader stuff, free type. So what are the uniforms? Right, we have a camera position and camera scale, but since they're never used, that's fine, I guess. So camera, okay, I can even probably remove them from here, so it's gone. Free glyph, we also link it with the camera vertex, and in the camera we have resolution, camera scale, and camera position and the time, so that should be fine. Right, so I didn't see any problems in here. So camera scale, let me take a look. So in the uniforms, so here's the camera position, and it does in fact correspond to this thing, and this thing does in fact correspond to this thing. Okay, so it should be fine. Can you save files with it yet? You can. Okay, so free C. So here's the camera vertex, and we do add this entire thing into the whole linking process, so I don't see any problems in here, but it still cannot find the corresponding uniforms, the camera scale and the camera position uniforms, even though it needs to use them somehow. So this is the problem. Okay, let's recompile the entire thing just to make sure that everything's fine. And let's do GDB. Can we break there one more time? So get locations. Free glyph.c 113. All right, so it's going to be run to enable, right? So, and we can try to display FGB uniforms, right? So here, not uniforms definition, uniforms. Thank you so much. Okay, so, and after that, still camera position and camera scale are not available. Even though we sort of explicitly said that we want to use them, They could have been optimized away, right? They could have been optimized away, but we do directly use them in this specific place. You know what I'm talking about? So, and that is actually kind of sus, in my opinion. Because, yeah, we use them here, and aren't they supposed to, like... Is that because I fucked up the type of the shader yet again? Maybe. So it's something because of my lack of knowledge. Okay, so the camera vertex shader, okay, that makes sense. And for the cursor or something. Can you check get uniform location? Oh, we have an expert in here. Can you check the uniform defs variable and make sure that the names are correct? I think I could. That's actually good. Okay, thank you. All right, so this is the cursor position. No, everything's correct. Because I already checked it. Yeah, I did in fact already check it. Classic chat. All right, so there's the camera scale, camera position. So we know it's something that if I add this thing in here, it is not really going to work. But can I do something like void camera camera position? Camera position. Is it because of that? This is so... Oh, I hate GLSL. I hate that it optimizes away something that is part of the interface. This is so fucked. Who designed this entire system? Like, why would you design it this way? It's just so error prone. It's so bad, and it caused so much misery in my life, like trying to debug all of that. Like, this is a part of the interface. You don't optimize away part of the freaking interface. Like, who the fuck thought it's a good idea? It's so bad. Like, this person should be straight up fired, seriously. Like... Anyway, it's like I would understand if it was like an internal thing. Okay, you can do whatever you want with an internal thing, but it's an interface. It's an interface of a module, and you just eliminated something that explicitly declared to be available. Holy shit. So bad. What people are doing, like, do they even know what the fuck they're doing? Okay, so we're gonna break free. Free glyph.c 113. Right, so we're gonna run this entire thing. So display RGB uniforms. Finally. Holy shit. This is so bad. So, did I... Okay. So, my hypothesis was correct, and I'm terrified. So, just because I didn't use the function from a separate shader module, the uniforms declared in a separate shader modules were optimized away. so fucking bad. Holy shit. It's just fucking worse. Why would you do that? Like, you're just intentionally trying to screw up the developer. Like, there's literally no reason to do that. Like, it's just like, at this point, you intentionally make the life of the developer miserable. Just intentionally, like, ill-intended way. Like, why? There's literally no reason to do that. I already like got burned by that so many times, and I still don't find justification of doing that. Like, it's just so bad. All right, I'm sorry. It's just like, I've been working with OpenGL for some time. I still don't consider myself OpenGL expert, but I've been working for quite some time, and I still don't understand why it's doing that. It's just like, yeah, it's just to make the life of the developer miserable. That's the only explanation I can see. Oh boy, there's literally no other explanation. At least I didn't see one. Alright, so if I try to do that, and didn't really solve much problems, but at least it recognizes the uniforms, right? So at least it recognizes the uniforms. So we have a camera position, so we have a camera scale. Alright, so camera position, camera scale. So we do have them. So camera vertex, so that means there should be there. But still nothing is visible. Still nothing is visible. I wonder why. It could be because the values of the uniforms are incorrect. Right, so frag. Right, so this is going to be that. So what kind of uniforms do we have? It's the time and resolution. Alright, the same kind of thing. Alright. So if I do GDB dead. Break free glyph C. Right, so I'm gonna run this entire thing. Display FGB uniforms. Right, so at least we have all of the locations correctly. So the last three uniform locations are cursor height, and last stroke, which is fine. We don't really care about them. So the problem that I can see in here is that scale could be actually set to 0. Okay, that's cool. I think I found the last bug. Right, so I need to revert this thing, I suppose, right? Oh, okay, so that's fine. So here is the FGB. We set the camera position, and we need to finally set the camera scale. Right, so it's going to be 1F, the camera scale, and for now it's going to be just 1, right? So I think this is the last bug, at least the last obvious I can see. So after that, theoretically, it should show at least, okay, so it's showing at least something, okay, I can appreciate that. But it doesn't show the cursor. All right, so now we need to squash the box in the cursor renderer. Right. So we can take a look at the uniform locations in here. So if I understand correctly, in the case of the cursor renderer, it should know all of the uniforms. Right, so we can do GDB dead, and we're gonna break on cursor renderer.c. And this one is going to be, let's put 25 in here. Let's run this thing and let's enable. So I'm going to disable the cursor uniforms like this. Okay, so let's try to see how many uniforms we managed to get. We managed to get all of them. Okay, so it knows about all of the uniforms, which is nice. All right, so it recognized all of them. Could have actually looked into this function directly. I think the easier way to debug this kind of stuff would be to get uniforms from location, right? Then run this entire thing, and depending on the stack trace, right? So where we are. get uniform location, free glyph. Okay, so I'm gonna continue, and on the second one, this is a cursor, and then, yeah, it would be easier to actually look through all of this stuff. And we can display locations. Can we print them? Okay, so I can do something like add count uniform slots, right? And let's display. Okay, it worked, so I can just do something like this, and there we go. We got all of them. All right, that's pretty cool. Debugging techniques. GDB is pretty shitty, but you kind of get used to it. Just like Rust. Sorry. So, let me see if the cursor shader is fine. Alright, so this is the frag. By the way, I really apologize that I'm a little bit salty right now. This is because I'm in the middle of trying to debug a pretty nasty bug, right? So it's just like, and that's what makes me a little bit salty right now, so I really apologize for that. So once I'm done, I'm gonna be basically a teddy bear. All right. So everything seems to be okay. It looks like oh yeah, it's literally the same bug. All right, so this is the camera position, and I just need to set the camera scale. OpenGL is horrible. I hate OpenGL. All right, finally. What's going on with the t-shirt? It changed color every minute because it's a shaders. All right, so finally we have everything working. So I wonder if you can have like a general function that updates all of the uniforms. If you know what I'm talking about. So each individual of them. So refresh uniforms. Like I really would like to have something like that. Right, so it takes the resolution, time, camera position, camera scale, cursor height, and also cursor position, but I'm not sure where do we set the cursor position. Also light stroke. I don't think it's gonna work that well. But yeah, so here we have the uniform shite, I suppose. So what we did in here, we introduced the uniform thing. Right, the uniform thing. We also removed a couple of stuff. So there's a lot of things in here, and I'm not sure if I can separate them. But what I can do, I can just commit everything and say introduce uniform registry or something. Introduce uniform registry. Right, and yeah, there we go. So now we have a scale, and you can kind of control that scale if you want to. Right, so we have a camera position and camera velocity, and on top of that we can introduce something like camera scale, right? And by default it's going to be 1, and you will be able to control it however you want. So if we take a look at the camera scale, this is going to be camera scale, camera scale, and this one is also camera scale. Camera scale. There we go. All right. So semicolons. Yes, follow the semicolon. Anything else? Anything else? Looks like it's fine. All right. Okay, and let's try to maybe hook up something into modifying the camera scale. For instance, we could try to you know, handle the mouse wheel, right? We could try to handle the mouse wheel and do something about that. Or another thing could be that when you don't have anything, right? When you don't have anything, we zoomed in really closely, right? So if you take a look at the camera scale, right? So this is going to be maybe something like this. we'll have to recompile the entire stuff. And as you type more, we sort of zoom out, revealing more and more code. You see what I'm talking about? So initially we're something like that, right? And it's going to be something like this. So the question is, how much code should we have even? Right, so this is initially how it looks like. Right. So I suppose it could depend on the amount of glyphs we're trying to render. Right, so at any point you can always look into the free glyph renderer, right? Free glyph renderer, and you always know how many glyphs you try to render, right? And the more glyphs you have, the more zoomed out you're gonna be, right? So, and what I'm thinking, so we know the capacity or something like that. So we know the capacity. Could it be dependent on the capacity? Probably not. Maybe it's gonna be actually up until a particular threshold, right? Up until a particular threshold. So let me see. Camera scale. So first we render everything. And where do we update the camera? Let me see where we update the camera, right? All right, so this is actually pretty cool. We are updating the camera after we requested to render all of the glyphs, right? So that means this is where we can try to do that. So here is the... and we don't clean everything, which is nice. Oh no, okay. So maybe I have to actually do something like this in here. Size glyphs, glyphs count. So here's the glyphs count, and after that, render line sized and everything, FGB, freeglyph.h, glyphs count, and we're gonna reassign this entire thing in here, glyphs, glyphs count, there we go. And so in here, cursor, it's not really cursor, it has to be camera. Where is the camera update? Okay, here it is. So the camera scale, so essentially, when you have a 0 glyphs requested to render, what I want to do, I want to be at the maximum zoom level, right? I want it to be at the maximum zoom level. So in the maximum zoom level is going to be 3, right? It's going to be 3. And as we grow, that value is going to be reversed up until like 0.5 or something. I'm not even sure. So the thing we can do, we can take the glyphs count, all right, convert it to maybe float or something, and divide it by some sort of like a big value, right? So maybe it's going to be glyph zoom out glyph threshold, right? Zoom out glyph threshold. And maybe I'm going to actually define that thingy somewhere here. Define zoom out glyph threshold, and let's say that we're going to have thousands of them, right? So, and here we'll already convert everything. So this is going to be some sort of a value t, right? But we want to actually, so if it's bigger or smaller, we want to make sure if the glyphs count threshold, right? If the glyphs count threshold, is greater than this thing, it is always going to be equal to that thing, right? So if it tries to, you know, go over this entire stuff, right? If it tries to go over this entire stuff. right? Then we divide it, and at some point it's going to be 1, but again, we want to inverse it, right? So the more glyphs you have, the more zoom out you're going to be, right? So the more zoomed out you're going to be. And we want to sort of linearly interpolate, right, from 0, 0, 1 up until 3 with this specific value, right? So we want to have something like lerp in here. So essentially, the more things you have, right, the more things you have, the smaller this value will become, right? The smaller this value will become. So the closer you're going to be to this part. Okay, so maybe I made a logical mistake somewhere, but I mean, it's going to be visible, right? If I made any logical mistake, it's going to be visible, and we're going to fix that. So it doesn't really matter. Okay, so we don't have a lerp. And let's actually add it. Do we have a mathematical stuff in here? I think a lerp is kind of related to linear algebra. So we're going to put it in here, I suppose. So this is going to be lerp f. Right, so it's going to be float a, float b, and float t. So let's actually quickly implement this into, I think it's going to be L.C. Right, so, and this one is going to be a plus b minus I multiplied by t. So there we go, we have a linear interpolation. It's going to be lerp. We're going to have lerp. All right, so is it going to compile now? Hopefully it will compile and do something. So interesting. So yeah, we update the camera scale. So then on the next iteration is going to be somehow working, hopefully. Doesn't really work that well. Don't see it working. So we can actually try to... okay, so that makes sense. So at which point, maybe it should actually grow a little faster. Maybe the threshold is too big. Let's put the threshold to be like 10. Maybe 100. Yeah, I think 100 should be all right. It's going somewhere, for sure. Huh. It doesn't do that smoothly. Right, for sure. Okay, so if we try to do it like 50, what about 50? I think 50 should be... And of course it should be a little bit more like smoother. If you know what I'm talking about. Yeah. So what about 30? I wonder if it could be computed on the shader, right? Because we could pass the amount of glyphs to the shader or something like that, and that could be computed on the shader as well. Yeah. So let me see if I can change the this one, right? So maybe it's gonna be like 1 in here. So it's going to be stdio. So then, and at some point it just like becomes this kind of thing. All right, so this is going to be the initial thing. Okay, so I would like it to be actually a little bit more smooth, if you know what I'm talking about. Right. So to make it a little bit more smooth, it should be probably the same thing as with velocity and position, right? So there should be like a target velocity and the current velocity and whatnot, and we should update everything accordingly. So camera scale, right? So here's the camera scale, and we need to have a camera scale velocity. Camera scale velocity, and this initially it's going to be 0, right? So where's the camera scale? This is where we set the camera scale, and camera scale plus camera scale velocity, right? So camera scale velocity, and we need to multiply by data time. There we go. But this camera scale velocity also has to be computed based on the rest of the things, right? So we'll have to put this entire stuff, in here, and let me see. So it's camera scale velocity, and it is going to be essentially the same as with the yikes. I actually confused myself. What the fuck? All right. So let me see. So here's the velocity, scale velocity, and what I do essentially is camera, the current scale, right? The current scale, the target scale. Ah, I see. Oh, okay, so I already confused myself. Okay, so this is basically what I want to do. All right, so I wanted to have this thing, right? So the target one is minus the camera scale, right? So this is minus the camera scale. Yep. And it also multiplies by 2, but I'm not sure if we need to multiply it. But we can multiply it by 1 just to have some sort of like multiplier. Just to have some sort of a multiplier. All right. So, all right. I think now it is actually zooming out a little bit smoother, if you know what I'm talking about, right? It is in fact zooming out way smoother than it was before. So, yep. Maybe it should continue zooming out, but that means we'll have to probably increase the threshold. Right, increase the threshold up until 100. And all right. So, and in here we probably want to go like half of that, and maybe here it's gonna be 2 or something. So yeah, we'll see. We'll see how it goes. So now it should be a little bit smoother. Right, so now I just keep typing things. stdleave.h. So I think zooming out should not be based on a glyph count. 1, 2, 3, 4. It should probably be based on the maximum width of the line and maximum height. And this is something that we can actually easily get, I think. I think it should be possible to get this kind of stuff, this kind of information. Yeah. So the reason why I try to use the amount of glyphs is just to see how this entire thing would look like, and this is the easiest way to think. Right. I've seen people in the chat screaming, but what about stuff and stuff and stuff? Calm down, we are experimenting, right? So what I was trying to see, I wanted to see how this effect is going to look like. So I picked the easiest, the dumbest solution I could come up with, absolutely freaking dumb, but it's sort of it's sort of close to what I want, just to see if I'm even moving in the right direction. This is how you do software development. You don't jump into implementing something without even knowing if it looks good or not. People, calm down. It's insane. And it's just like everyone's going crazy. No, this is not correct. This is not how you're supposed to do that. No. Calm down. Everything's going to be implemented properly eventually. This is how you experiment, right? So this is research and development. Get it? Get it now? So I think maybe it's a problem of education. Sometimes I feel like it's a problem of the education, because it makes people think that you're supposed to write the perfect solution first time, character by character. Where do you get that? So, like, seriously. All right. See what I'm talking about? You see? All right. So we're gonna implement everything, right? Don't worry about it. Don't worry about the chat. Maybe I need to make another cup of tea. All right, so this is a Victor Monov. Okay. Okay, so we already iterate through each individual line, and for each line we already know its size and whatnot, right? We already know its size. We can, you know what, we can probably maybe use. It also depends on what lines are visible, right? So it pretty much depends on that too. Can we calculate the maximum actually line? So this is not a glyph count, max line size, right? So it's going to be max line size. And here we're going to do something like this. If max line size is less than the line size, right, if less this line size, we're going to do something like this, right? Max line size, there we go. So let's go through the compilation errors. Okay, so we don't need that because it is not used anymore. And we can actually use max line size in here too. Max line size. Is it gonna work? Is it gonna work now? Yo! Alright. So, So it's kind of going in more or less right direction as we type. Okay. So, but it actually have to go a little bit faster, I think. So this is maybe I can actually do 2, right? I can actually do 2 in here as well. Maybe the okay, the threshold has to be small. Yeah, it definitely has to be smaller. Maybe the threshold should also try to fit as many of them as possible, right? But maybe not. We can put like 10 in here. Maybe 20. It's kind of strange that it tries to go to a particular thing. Right, and all right, so number 30. std leap. I think that looks a little better. So now it's based on the maximum line. Right, it's sort of based on the maximum line. Could be even more interesting, but yeah. Printf hello world. It's too aggressive, I would say. I think it's a little bit too aggressive. Yeah. Okay, that's pretty cool. I'm already streaming for 3 hours, so for 3 hours. Let's make a small break. All right, so I would like to make it sort of like a little bit more accurate, right? So it would be interesting to make it more accurate. And the way we can do that is probably maybe knowing the actual length of the biggest line, right? Some sort of a biggest line. Try to precisely fit that line into the width of the screen. So that will require a little bit of mathematics and stuff like that, but I don't know, maybe we can do that. All right, so we do have the particular width of the line, right? So, and it's roughly like that, right? It's roughly like that. So this is the width of the line. And we want to make the width of the line, so maybe it's going to be WL, right? We want to come up with such a scale, we don't know what it is, right, which will make the width of the line appear as the width of the screen, right? So that's basically what we want to do. To understand that, we need to know how the scale is even used in the entire thing. To be fair, I think scale is literally that, right? So yes, let's actually call it S, maybe scale, right? So scale is literally just multiplied like this. And I suppose the actual scale has to be simply this thing divided by this thing. Yeah, okay, so that was actually easier than I thought. All right. It does make sense, right? Rather, I think it does make sense. Okay, because that's precisely how we use the scale even in the shader. Right, so if I take a look at the camera, so we just take the whole scale, right, and just multiply it by that value. So, and then we just do the rest of the things. Okay, so the next thing we need to do, we need to know the length of the line in pixels, right? We know the length of the line in characters, and this is not particularly useful for us. We need to know that in pixels, right? So the way we actually render the line, right? So we do, where is it? Render the line sized. So we call this function. This function should know the size of that thing, right? So let me go free glyph.h, here is that, and where is the free glyph.c? Oh my god, Emacs. Okay, stop asking questions. So annoying. Okay, here it is. So we do maintain, I think we do maintain some sort of a pen. Where is the pen? This is the position. Okay, so this is how we maintain the entire thing. So, and the actual length is going to be the difference between the original position and the final position at the end of the rendering of the line. So maybe we could pass the position by the pointer, right? Maybe we could pass it by a pointer, and then that way we know where pen has finished, right? And then we can take the difference between y's, and that's going to be our length, right? That's going to be our length essentially. Yep, I think so. All right, so let's actually pass it by a pointer. Okay, so in here, so here's the position, right? So const char vec to f begin, right? And then we're gonna have not char. Why do we do char? Vec to f, and it's gonna be copy of begin, and we're gonna do it like end. Do we even use this function anywhere? We don't. Okay. So in the main now, we can know the size of the thing by doing just y minus begin y. Max line len. This one is going to be a line len. Right. If line len is greater than max line len, we're going to assign it like this. Okay. So not size. This one is not needed, of course. This one is dead, pretty much. Alright, so in here, the actual scale, the sort of target scale, right? Float target scale is something like this, right? So, target scale, underneath that. And I suppose we need to take max length, line length, and divide it by screen width. So this is going to be screen width. Okay. And I suppose the thing we need to do in here is, in fact, maybe take the opposite, right? I think we need to take the opposite of that. Okay, so this doesn't work for some reason. I don't really know why. Okay, so scale, if it's 1, it's gonna be, but it's not gonna be that. We want this thing to appear as that. Why it doesn't work? I have no idea why it doesn't work. So maybe I'm just misunderstanding that grossly. Could be, yeah, it could be special case, right? Yeah, it sounds like a special case, but I'm not quite sure. We can wrap it around, but yeah, it's kind of dangerous. I think it's kind of dangerous. For some reason it doesn't make any sense to me. So where is the mistake in my reasoning? I don't see the mistake in my reasoning. So if I go to the camera, right, if I go to the camera, So the way it works, okay, so the scale just applies to the position. So we move everything, and then we scale it, right? So that will make the everything appear a little bit bigger, proportional to the scale itself, right? So proportional to the scale itself. That makes sense to me. So it means the scale, it controls that. So here's the, I suppose it's the other way around. L multiplied by scale, right? So we have length multiplied by scale, and we want it to be appear as this thing. So that means the actual thing in here has to be S divided by WL. But what if it's equal to 0, right? What if it's equal to 0? So we have to treat that in a specific way, right? Right, so it would make sense if we just, wrap it, invert it like this. Okay, so I think I found the mistake in the reasoning. But if the max len is equal to that, it's just not gonna work really well. So one of the things we can do, right, we can assign this to be super close, right? And if max len is greater than 0, maybe even, yeah, greater than 0 specifically, we can reassign this entire thing, target scale, to be that. Right, so, and as we grow bigger, it should probably work properly. Did it compile? Excuse me. Oh, it should be like, okay. Let me make it 3. Okay. So if I open this thing in here, it doesn't work. Okay, so let's actually go into the debugger. It's gonna be that break at main.c 141 src main, and let's see what we got. So we're gonna enable this, and let's take a look at max line len, and it's 0. It was never actually updated. Nice, thank you so much. Okay, so it's initially 0. Is it initially 0? It is initially 0. Right, so okay, I don't see any problems in here. Then we take the end. Okay, so let's actually go to, I don't know, here. If it's bigger, it has to be equal to something, like, come on. All right, so, and y, maybe it has to be absf. Yeah, probably. Oh my god, I see. fabsf. So let's try to rebuild this entire thing. Let's try to rebuild it, and let me see. So where did it break? Maybe we can just try to run it as it is. Still doesn't. Where did they make a mistake? Wait, what? Oh, it's so painful. Okay, GDB dead, and let's go somewhere here. It's gonna break main.c97, right? So it's main.c97, run src main, right? So to enable, let's go begin. So then end. Okay, X. Holy shit. Where were the backseaters when I needed them? Not a single backseater told me that I'm actually using the wrong thing. Never useful. Alright, so now let's give it a try. Okay, so it's actually, that's pretty cool. I think we can sort of like cap it to a particular size, right, we can cap it. So essentially, if target scale is greater than 0, we're also going to cap it to target scale equal to this. So it's never going to be bigger than that. So that way it's going to be, I think, more or less interesting, right? Not fucking bad. So now, okay, and as it okay, not freaking bad. Right there. So we can actually set the camera maybe not to the center but to the right side, if you know what I'm talking about. So that way it's going to be even cooler. So the camera position, right? So here's the camera velocity, then a cursor position, but I also want to do vec2f subtract vector2f half of the width, I suppose, right? So the height is going to be 0. It could be actually something else. We'll see how it goes. Yeah, but then it's going to be minus screen width, maybe even screen width multiplied minus 0.5f, and that should be something. Right, probably made a mistake somewhere, but whatever. So I'm not sure if it's a plus or minus, right. I cannot see shit in this mist. Oh fuck, I see. Let's go back. So I suppose the camera position should be sort of clamped to be not... It also depends on how we treat the camera position, if you know what I'm talking about. So maybe we can fix that in the shader. So here's the point: camera position plus that, but also minus half of the resolution. Could that be a good thing to observe? Plus half of the resolution. Oh, and probably need to recompile into a thing, of course, because that also messed up some other things. Nope. Yep. So maybe that one has to be minus. Nope. Okay, so we're gonna keep it like this then. Gonna keep it like this. We're gonna keep it like this. Alright. So because it's centered like that, it's kinda doesn't make it fit properly, does it? It just depends. It just depends. I suppose this is all right solution. More or less, I would say. Right. 1, 2, 3, 4. More or less. 1, 2, 3, 4. And let's try to write something in here. So we're trying to make sure that everything sort of fits in there. RFC, RBD. So maybe we can recheck if RFC is less than 2. That means we need to apply something. Yeah, there we go. So it sort of like zooms out according to to this thing. To be fair, it feels like maybe the zoom, like there's like half of the length here. Half of the length in here. Does the camera adhere to the caret? I don't know. What do you mean by that? What is this question? I don't understand. Oh, right. So that's pretty cool. I'm pretty sure the encoder was actually going crazy. So I'm really sorry for the encoder. Okay, so don't really understand why it's like half of this entire stuff, right? So it obviously has to be a little bit bigger than that, but I don't know. What if we maybe if we divide it by 2? Yeah, we need to try to divide it by 2. Let's try to divide it by 2. I think it's gonna look a little bit better. Okay. Kinda. Nah, it's the same shit. What if we multiply it by 2? Okay, so it could be something like this. Oh, did I recompile it, by the way? I don't remember. Don't remember if I actually recompiled it. Way too dang, bruv. Okay, I did. Okay. So let's do 2. All right, so that looks more like it. Yeah, it looks like it tries to fit the whole thing in there. Right. Tries to fit the whole thing, but at the same time does not allow you. So if we remove this thresholding, I think it's going to be rather interesting. Right. Because it's first will go really close and only then it will zoom out. Yeah, as you can see. This is actually fucking crazy. So yeah, it tries to fit that line perfectly, leaving no room for, you know, padding or anything like that. And it makes sense if you actually do the full screen, right? So let me quickly disable the chat so we can see a little better. Yeah, so I think in the full screen it makes sense a little bit more, right? So it's really aggressive when it does this kind of stuff. What the fuck? Yeah, I guess that's how it's intended to be, right? So as you go further, but I'm not sure. Maybe that thing, yeah, clamping, like not having 2 in here was a little bit better. I don't know. Maybe that was a little bit better. Okay. Yeah, because it also gives you a little bit of room to look at. Yeah. Okay, that's pretty cool. But I'm gonna leave this thing in here. What do you guys think? Is it cool? Is it cool? Is it pretty cool? Isn't it? I don't know. Tell me. So cool? Okay. Alright. What else do I wanted to do? Yeah, I wanted to actually adjust to the lines that are visible on the screen. But it's kind of difficult to know what's visible and what's not visible on the screen. You know what I'm talking about? So which lines are actually visible? It actually greatly depends on the zoom. It really greatly depends on the zoom. So Okay, so first we look at the camera, right? We try to render the lines, and as we render the lines, we can actually know the glyphs and stuff like that. We have the whole collection of glyphs. We can actually analyze them. We can actually now analyze them and decide what's going to be the zoom and what's going to be the next, the rest of the stuff. Yeah, it's rather interesting. So the whole thing will be very much dynamic, right? It's not really deterministic. It always depends on initial conditions. So the thing that is going to be visible next, it just depends on what's visible currently, and what's visible currently depends on the current scale and the current thing. So it's going to be very much dynamic system. Right. Okay. So that's very interesting, I think. Yeah, I'm gonna actually probably put it to doing that. Okay. So max line. So to do the max line len should be calculated based on what's visible on the screen right now. All right, so let's actually do a committee. What did we do in here? Introduce dynamic camera scaling, and I'm gonna create a pull request for this specific feature. Dynamic camera scaling. All right, so did we push everything? Everything is officially pushed. And let's take a look at how many changes we made. I think we made a pretty decent amount of challenges. We removed a lot of shit though. We removed like a legacy renderer and stuff like that, so it's pretty cool. Does anyone have any questions, boys and girls? Do you have anything to ask me about this text editor? Feel free to ask them in the chat right now. Copilot when? Well, GitHub didn't really accept me in their program or something. Copilot. So I actually signed up, and yeah, access is limited to a small group of testers during the technical preview. Sign up today for you're already on the waiting list for GitHub. I will notify you when. So yeah, they didn't accept me. So nobody likes me. What can I say? How to make a rainbow effect? I do that with the HSL animation, right? So let me show you. Shaders, and I think it's located somewhere in free glyph frag. Yeah, so the file, so you can find the source code of the thing in here, and you're interested in a file called free glyph frag. This is the shader that is responsible for rainbow animation. So what I have in here is I have a simple function called HSL to RGB, right? What it does, it converts HSL color representations to RGB color representation. So HSL. HSL is actually pretty cool. Hues. Okay, so let me actually find it. I'm gonna use Russian. I hope you're okay with the Russian language. It's freaking Google. I mean, come on. Google cannot comprehend that there is bilingual people and multilingual people, right? It's just like it's outside of the reach of the Google. Like, what? You speak 2 languages? Impossible. Human people are incapable of speaking 2 languages. Okay, so it's a hue, saturation, lightness. What's cool about this representation is that the actual color is represented by hue. It's a single value, and this is the color. And saturation and lightness is modification of that color. So saturation is how much of that color you have, and lightness is how bright or dark it is. So for a human being, it is actually easier to think in HSL rather than RGB, right? So so essentially what I do in here, I have a function that takes HSL and converts to RGB, something the computer that can understand. And what I do in here, I basically animate hue part of HSL, convert it to RGB, and then display it. The way I animated it is that I basically take the current time, the amount of seconds since the program has started, right, plus the X coordinate of the pixel, plus the Y coordinate. and that's the hue, right? And x plus y gives you this sort of slanted, like diagonal thing, and plus time gives you the effect of this line moving like that. So, and this is the hue that I use, and that's how I create this animation. You see? Does it make sense? So yeah, I'm basically animating hue part of the HSL representation of the color. Does that answer your question? Do you have any other questions? Okay, you're welcome. I want Sabatka to try Copilot. Yeah, I think it's closed because it generates a lot of shit, so... but then how is it rendered? It's rendered with OpenGL. So, with this thing. So, and yeah, basically the entire process is encoded within a fragment shader, right? So this is not a C code, this is a GLSL code. GLSL. GLSL is an OpenGL shading language, right? It's a language that describes the program that runs on GPU. So essentially, shaders are programs that run on your graphics card, not on your CPU, right? So this is the code that is executed on my graphics card. And what it describes how I transform the color of each individual pixel on the screen. So yeah, for each pixel, I know the coordinates of the pixel, and I know the current time of how much the program was running. So, and I pass this time from my CPU to my GPU via a mechanism called uniform. Uniform is just a way to pass some sort of a value to your GPU, so a shader, a program running on your GPU, can use that value to do something, right? So I pass the value, pass the time, and I know the coordinates of the fragment, and based on that I compute the hue, and then I tell the GPU, okay, so display that pixel with that specific color, and that's how I create a rainbow effect. So make sense? So that's roughly how this kind of stuff works. There's a lot of technical details to that, but this is like a, you know, high level picture. So does anyone have any other questions about this text editor that we're developing? It's a joke text editor. Don't take it seriously. So I'm developing it as a joke for recreational purposes, right? And also to learn OpenGL a little bit more. Thank you. You should be a teacher. I haven't heard that in a while. So, and the way it is so fast is because it's executed on GPU yet again. So GPU works slightly differently than CPU. Just a second. All right. GPU works differently than CPU. So in this case, it doesn't go sequentially and iterate through each individual pixel, and for each individual pixel it calculates what kind of color it should be. No, it doesn't work like that. GPU has a lot of small cores, small like dumb process units, and what it can do, it can pretty much assign one core per pixel, but not really per pixel. Well, it depends. I don't really know how exactly GPUs work, but it can assign a lot of things and compute all the pixels sort of simultaneously, right? So that's why it's so fast. If you try to do something on CPU on a single core in a single-threaded program, it's going to be very, very slow because it will have to iterate through each individual pixels. But on a GPU, it does all of the computations like simultaneously. Like instantly, simultaneously, and that's why it can animate so smoothly. So yeah, the text editor is already on GitHub. You can actually find it here. It was on GitHub since the day one, right? Right, and you can find how the entire thing started on this YouTube channel. So I think on this YouTube channel we have a playlist on how it started. Right. So let me see. So it's a Coding Daily, right? So daily. Unless you're Windows terminal, it's not that instant. Okay, so here's the text editor. Right, so here's the playlist. So, and this is literally how all of that started. So we started literally with empty file. Here is the empty file we started with. This was the beginning of this text editor, literally. So then this code turned into this eventually, as we wrote more and more code, refactored more and more and stuff like that. So I'm trying to document the entire process. So there's been 1, 2, 3, 4, 5, 6, 7. This is 8th stream of the text editor development. So the 8th stream. So yeah, does anyone have any other questions about the text editor? Okay. All right, I think I guess I'm gonna go. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you next time. So maybe tomorrow. I do plan to actually stream more text editor tomorrow. So I see you all tomorrow, and yeah, check out all of the links. If you're watching that on YouTube, check out the description. I actually put all of this stuff in the description. So, and I'm gonna go. Thanks everyone for watching. Love you.